Hey, my name's Grayson. I'm from PaperCut Software. Look, my role is the digital lead for PaperCut, and my team looks after most of the marketing technologies that we use to make PaperCut commercially successful. I'm here again. I'm really pleased to be welcomed back to present at HugoConf for a second year in a row. This year, I'll be presenting about building enterprise-grade search experiences using Hugo and other technologies. So, we are PaperCut. We make software that makes printers better in so many ways. Software that helps with printer driver deployment, enable users to self-enroll, stop printouts being seen by unwanted eyes with secure release features such as Tap ID to print, allow you to charge your users to print. If you happen to be a solo techie in a business, as I've been many times before, and you're managing IT environments, check out papercut.com so you can forget about your printers. So I really need to start at the beginning. PaperCut has had serious print applications in market since 1999. We have 4 major products and some smaller free applications we offer to you, the sysadmins. These major applications all have varying levels of complexity and different levels of engagement with website content. PaperCut MF is our most popular application, and its users make up most of the visitors to papercut.com. This has led to a large website of over 4,000 pages, made up of product manuals, knowledge base items, and known issues. We've heard complaints for a long period of time about how difficult it is to find some answers to common questions because often content is duplicated across multiple locations, but referencing different products or industries. To me, this has always been a problem with how search engines work, with a focus on relevance of keywords and volumes of traffic to that location. For us, this meant users not using PaperCut MF generally had a poor experience using search. We've also had a mixed experience using our on-site search. Early days, we used Google Custom Search. I'm not sure if any of you remember this, but it relied on scraping your website, and deep websites, sometimes it would lose interest digging further than a couple layers. Later we moved to a Swift-type solution, a SaaS-managed version of Elasticsearch. This solution really has many of the same problems as Google Custom Search. It was built on PHP, so naturally we wanted to move away from it. Finally, we'd lost confidence in the service provider. A little while ago, they forgot to renew their SSL certificate, and we had a 2-day outage. So for us, it was time to look to the future. So before I move into how we picked our solution, I want to talk about what this isn't. I'm managing a massive website with a diverse customer base. Often with search applications, you need to consider your unique needs. Large websites or e-commerce need the ability to organize in topics and be able to finally configure searches to focus on commercial outcomes. If you're running a blog or a small simple website, this is not the approach for you. I'll do a little plug here. I would strongly recommend checking out open source solutions like PageFind, which is managed by Liam at CloudCannon if you're looking to service smaller needs. I was looking for a couple things when looking for a new service provider. A simple-to-use API solution with documentation that most engineers can easily pick up. Future-proof solution that already had machine learning and semantic search in its development path. SaaS hosted. I have no interest in managing servers internally. The ability to filter by product type. A back-end panel which could be provided to our support and service staff to adjust search results as required, and the ability to supply new content programmatically rather than rely on a web scraper. So let's talk about our solution of choice. We chose to partner with Algolia because it met all of our requirements that I just talked about. The way we've set this up is papercut.com is made up of multiple micro repositories. We use this to reduce build times and tailor to the needs of our unique content. We use the build processes of these micro repositories to push to the Algolia API changes to content which build an index at Algolia. Then we've built an isolated Hugo environment for search which uses Algolia's native APIs to request search results and add filters as needed. From here, I'm going to hand over to Alicia Nolan from CloudCannon, who's going to give you a technical demo of the final solution. Take it from here, Alicia.
Thank you, Grayson. As Grayson mentioned, my name is Alicia and I'm a web developer at CloudCannon. Apologies for having no video and probably average audio. I'm currently on holiday in Bali, so my setup isn't ideal. Today, I'm going to talk about the technicalities of using Hugo, JavaScript, CloudCannon, and Algolia to make a search interface for PaperCut. So getting into that, the first thing to do is to get your site's page data into Algolia. Hugo makes organizing that data easy. You can use a layout like the one I have open here to loop over the pages in the site and get any information for them. And it stores them into a JSON file like this one here. And Hugo generates this on build. Then you have to get your data into Algolia. I do that through this JavaScript file and also a CloudCannon post build, which calls the script after your Hugo build's finished. When you call the script from here, it passes through two parameters. The first one being the JSON data file that's generated by Hugo, and the second one being an output file that stores the object IDs and the time from the last indexing. And then back in this file, it compares the object IDs that are in the site now to the ones that are in that last indexing file, sees which ones have been deleted, don't exist anymore, deletes them from Algolia. Similar with the update, it looks at the Git history of the files and that last indexing file, figures out which ones have updated, updates them in Algolia. Any that haven't had changes are just ignored. And then the last step of this is to overwrite that last indexing file with the new information of objects and time. PaperCut also didn't want all of the pages to be indexed for the search, and that was really easy with this approach and the microsite architecture that they have. The layout is generated for all of the microsites, but if you don't want the site to be indexed, you just don't add the script call in the post build. And then looking at the Algolia interface, you can see that all of those pages have their data in here, and that's before you've even started setting up your search interface. So that makes testing really easy for that part. For building the search interface, Algolia does have a pre-built UI. However, most of those weren't what we were looking for, so we went more down the custom implementation route. But we did use autocomplete, which is provided by Algolia. And then even when you're using their pre-built components, you can still change up the styles to match your own design system. So the layout file for the search page is here. Mainly this sets up the filters, does some logic around those, and sets up any containers that are needed by Algolia, but mostly just the filters in here. So moving on to the logic behind the search interface, the entry point is this search JavaScript file, which gets any page elements that are needed. It renders the autocomplete search bar and the query suggestions plugin onto the page. Both of these are provided by Algolia, just with some custom rendering. Then there's a bunch of event listeners watching for any changes in the page, whether that's on load or something that the user inputs. And then whenever there is a change, this search query update function is run, which passes the search parameters like the query, the filter data, which page the user is on, and passes those to the Algolia search helper. And then whenever a result is returned to the helper, it knows that and it calls render hits and render pagination to render those onto the page. Moving into the results script, you can see that it loops over the results from the object that Algolia returns, manipulates them for how we want, custom CSS classes, making things more human readable, that kind of thing, and then it puts those onto the page. It also has some logic around the merchandising cards that are shown on the right-hand side of the search results. The merchandising cards are done using Algolia, using the promote results, puts them at the top, and then adds some custom JSON data to define how they should look. And this file takes those properties and renders them onto the page as well. The pagination is similar. It takes the data from the objects that Algolia returns and puts them down with the custom CSS and structure that we want so that the pagination matches the styles that are in other places on the site. PaperCut also wanted to be able to see some analytics such as the click-through rate for search results. So this file here handles that. It watches for search result clicks and then sends the information about the result to the Algolia Insights API. PaperCut can then view these analytics in their Algolia dashboard. This shows what the search term was, how many people are searching for it, and if they click through to a result from that search term. PaperCut can then use this to see where the results were by this average click position, and then they can move results up, change the order so that people are more successful with their searches. So that's an overview of the technical side of implementing Algolia for PaperCut search. Thanks for listening. I'm now going to hand back to Grayson to wrap things up.
Thanks, Alicia. So there you have it. This is how PaperCut's built an enterprise search experience on Hugo, powered by Algolia. I hope you've enjoyed the presentation today and enjoy the rest of the conference.